Okay, up until this point, you have learned that 1 mole of anything equals 6.022 times 10 to the 23rd things. Okay? In chemistry, those things will likely be atoms or molecules or formula units, which is what we typically call ionic compounds. Okay? So we're going to use this concept to convert between moles and atoms, molecules, or formula units in student exercise 4 and student exercise 5. So if you take a look at student exercise number 4, it says calculate the number of sodium atoms in 0.120 moles of sodium. So what I want you to do is set up the problem like this. 0.120 moles of sodium is in the upper left-hand corner. Whatever unit you begin with, it follows you onto the diagonal. So moles of sodium is going to get written down on the diagonal. And we're going to sodium atoms, so I'm going to write sodium atoms up on top. Now, the number 1 is next to mole, so that's why I'm going to write the number 1 on the bottom next to moles of sodium, like this. And then 6.022 times 10 to the 23rd is next to atoms, so that's why I'm going to write it right here. So it looks like this. So we're going to be multiplying, and your moles of sodium units will cancel. So when you put this into your calculator, it should be 0.120 times 6.022 second E 23, enter, like this, okay, if you're using a graphing calculator. We're starting out with 3 significant figures in 0.120, so that means I want 3 significant figures in my final result. So here your answer will be 7.23 times 10 to the 22nd sodium atoms. Okay? So anytime you're converting from moles to atoms or molecules or formula units, you will be multiplying by Avogadro's number, which is 6.022 times 10 to the 23rd. Okay. In the next example, student exercise number 5, calculate the number of moles of potassium in 1.25 times 10 to the 21st atoms of potassium. So we're going to set it up so it looks like this. Okay? And we're going to have atoms of potassium on the diagonal. And then we're going to moles, so I'm going to put moles up on top. The number 1 is written next to moles, so that's why I'm going to put the number 1 on the top next to moles of potassium like this. And then 6.022 times 10 to the 23rd is next to atoms, that's why I'm going to put it on the bottom. So this time we're going to be dividing. So when you divide, it's going to be 1.25 second E 21 divided by 6.022 second E 23, enter. Do not put in a multiplication sign for this one right here and this one right here because it will give you the wrong answer. Okay, and that's not what we learned to do in the fall. So you want 3 sig figs in your answer. Your answer will either be 0.00208 moles of potassium, or if your calculator is in scientific notation mode, which is fine, it'll be 2.08 times 10 to the -3 moles of potassium like this. Both are the same. Okay, so anytime you're converting atoms or molecules or formula units to moles, you are dividing by Avogadro's number, which is 6.022 times 10 to the 23rd. Okay, so this is what you're doing on Mole calculations 1 worksheet. You've got 5 problems. You set them up the exact same way. You need to include a unit in your answer. You need to have the proper number of sig figs in your final answer. And make sure you're including the substance that you're working with. If you're working with carbon, you should have the symbol C in your unit when you're finished. Or nitrogen would be N2, or carbon dioxide would be CO2, for instance.